Oh, I just got this started here. Uh, Step one, it's just a product rule. One derivative on a product gives you the product rule, which we know is true, so that's fine. Step two, usual situation, assume true for k. But because I use k, I have to change the k index to just I. And then step three is the required to prove the k plus 1 situation case. So we'll start from 2. So that is fg k, and we'll apply a derivative. So if we differentiate this, we'll get the sum for the I from 0 to k, ki f I plus 1 x g k minus I x plus sum 0 to k, ki f I g k minus I plus 1 x. So I'll increase the index on the first one. So I'll go from 1 to k plus 1. So then that becomes k I minus 1. And then I can drop the 1 here. So that just becomes I g. And then k minus I minus 1 x. No, plus 1. I minus 1 with a minus, yeah. Which is good. It's looking like that. Plus, and then I'll pull out the first one. So that's f 0 g k plus 1 x sum from 1 to k fi x, sorry, and there's a plus there, g k minus I plus 1 x, and let me think, and I'll pull the last one out here. So it'll be f0 x g k plus 1 x plus the first sum going from 1 to k, and then the second sum going from, I just have to save a bit of space, so I'll just write dot 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 here, and then the second sum from 1 to k as well, dot dot dot. And what I've done is in this sum I've just taken out the last one separately, so that would be k over, so that's minus 1, k plus 1 minus 1, so that would be kk f k plus 1 x, and then g, and then the I would be k plus 1. So that would be minus k, so it would just be 0 then. The coefficient here is 1, which I could write as k plus 1 0, f 0, x g k plus 1 x plus the two sum parts plus this piece at the end. And again, I can increase that to k plus 1, and it's still the same value. Okay, now I need to clean up a little bit here. So the first piece, k plus 1, 0, f 0, g, k plus 1, x. And these two sums now, they have the same index, so I can put them together. Same summation symbol. So that would be this piece. And this piece here. Oh, I've lost my little ki sum here. Ki binomial there. Okay. So that's ki minus 1. Oh, and these are actually the same, so I can take that out. Ki, and then f I x g k minus I plus 1 x plus the last piece there plus k plus 1 f k plus 1 x g 0 x. Ooh, squished in. Okay, so these two, there's a binomial identity here that can combine them. So that would be k plus 1, 0, f 0, x, g, k plus 1, x, plus the sum 1 to k, and that would be k plus 1, I. F I g k minus I plus 1 plus k plus 1 f k plus 1 x g 0 x. So what's nice is that first piece and last piece can be incorporated into this summation. So that would be the sum from 0, the k plus 1, f I k plus 1 I f I x g k minus I plus 1. And actually, I'll write it as k plus 1 minus I, just so I can match up exactly with what we're trying to get to here. So if you put in 0 here, you would get the first term. 0, 0. Yeah, you would. Yeah. So this is done. So step 4. 1 plus 2 plus 3. That means it's true when n is 1, 2, 3, etc. So the only thing that you might find unsatisfactory here is that you might want an elementary proof of the product rule. That's fine. That would be in a calculus book. It's not that difficult to prove. And the second thing you might want is a proof of this identity, that adding these two together would make this. And maybe I'll do that as a separate video, actually.